Here's a question. A window is in the form of a rectangle capped by a semicircle. I will draw that here. Here's the rectangle. Here's the semicircle. The width of the rectangular portion is equal to the diameter of the semicircle. Well, diameter of the semicircle is 2 times the radius of the semicircle. That equals the width. It doesn't say what the length is, so I'll just call it length. This is also the width. If the total perimeter of the window is 20 feet, what is maximum possible area? First of all, this is supposed to be 40 over pi. Well, I'm just going to draw it like this. 40 over pi plus 4. In other words, it's divided by the whole thing. It's not 40 divided by pi and then that whole thing plus 4. This one is 320 over 8 plus pi. And this one is 200 over 4 plus pi. Those are the answer choices. Got to draw them accurately. So I need to find the area, maximum area of this window. Area of this window is the area of the rectangle, which is width, length times width. But the width, I want to do everything in terms of the radius. Width equals 2 times the radius. So length, my R's look like V's. There we go. Width equals 2 times the radius. So the area of the rectangle is length times 2 times the radius. And then plus the area of the semicircle. Area of a circle is pi r squared. So the semicircle is pi r squared over 2. I got a dead spot on my screen, so the r came out a little funny. Well, I'm going to have to differentiate that. Hopefully this will be a upside down parabola, and the maximum will be the vertex of the parabola. Differentiate it, set it to 0. That'll give the vertex. But I've got this L in here. I've got to replace that L. So I can use a perimeter formula to do that. The perimeter is 20 equals. Well, the perimeter is this part of the rectangle, 2L plus W. And the W is 2R. The width of the rectangle equals 2 times the radius of the circle. Plus the perimeter of a semicircle. Well, the perimeter of a circle is 2 pi r. So the perimeter of a semicircle is just pi r. And now I'll solve this for L. So I'll subtract everything from 20. 20 minus 2r minus pi r equals 2L. I'll divide everything by 2. 10 minus r minus pi r over 2 equals L. And I can plug that all into the area formula and have everything in terms of r, so I can differentiate it. I'm going to take area equals the length times 2r. I'll put the 2r in front. It'll be easier when I multiply. 2r. Why do my r's look like v's? 2r times 10 minus r minus pi r over 2, and then plus pi r squared over 2, plus pi r squared over 2. That's the area of the semicircle. Then I'll distribute that r. Area equals 2r times 10 is 20r minus 2r times r is 2r squared. 2r times minus pi r over 2, the 2's cancel, minus pi r squared plus pi r squared over 2. Now I will combine like terms. I want to get this as simple as possible. Area equals, and that's going to be 20r minus 2r squared, and then pi r squared over 2 minus pi r squared. Well, negative pi r squared is like writing negative 2 pi r squared over 2. So negative 2 pi r squared over 2 plus pi r squared over 2 is negative pi r squared over 2. And I can further simplify that. Area equals 20r. I'm going to take a 1/2 out, minus 1/2 and the minus sign, times, well, that's going to give, I'm going to take the r squared out too. I'm going to put the r squared over here. So I divided out the r squared. I put it here to keep it separate. It's going to be easier at the end when I have to simplify. And then I'm dividing 1/2 out of both of these terms, putting that in front, negative 1/2. So 2 divided by negative 1/2 is 4. Or negative 2 divided by negative 1/2 is 4. And negative pi over 2 divided by negative 1/2 is positive pi. And then both of them have an r square in it. I factored out the r square and just put it over there because it's going to be easier. All right, so there's my area, equals 20r minus 1/2, 4 plus pi times r squared. Now I will take the derivative of this and set it equal to 0. The derivative of the area, and notice this is an upside down parabola because it's the r squared term is minus. So it looks like this, and there is the maximum is going to be the vertex. So the derivative of 20r using the power rule is just 20 minus derivative of negative 1/2, 4 times 4 plus pi times r squared is 2 times negative 1/2. The 2's cancel, so negative 4 plus pi r. And I set that equal to 0 to find the vertex. And I will subtract 20 from both sides. Negative 4 plus pi r equals negative 20. And so r equals 20. The negatives cancel out, over 4 plus pi. So that's the radius, 20 over 4 plus pi. I guess I better write that a little bit better. There, 4 plus pi. Now I will plug that back into the area. Here's the area formula. I will plug that back in to see what the area equals and come up with the answer. All right, so I'm plugging in 20 over 4 plus pi for r. So the area equals 20 times 20 over 4 plus pi. I'm just plugging in 4 plus pi for r, minus 1/2 times 4 plus pi times r squared. R is 20 over 4 plus pi, so times 20. That's why I put the r squared separate, so that I could easily square it and not have any problems. Equals 20 times 20 is 400. 400 over 4 plus pi minus, well, let's see. This is 1/2 times 4 plus pi. 20 squared is 400 times 400. And 4 plus pi squared is 4 plus pi squared. And then the 4 plus pi cancels with 1 power of the 4 plus pi there. 1/2 of 400 is 200, is 400 over 4 plus pi minus 200 over 4 plus pi equals 200 over 4 plus pi. That's the answer, 200 over 4 plus pi.